Hey, what's up, YouTube fans? So what I wanted to talk about in this video, right, is the absurdity, right, of drawing the line at the taxonomic family level, right, as to, the extent of how far common descent can go, right, to draw the line at the family level, the absurdity of that, right? So that is what commonly many creationists and major creationist organizations now will do is they will they will say that they agree with speciation, and to a significant extent, right? They believe that everything within a so-called, they would call it kind, right, is all related, and they would say that this generally goes up to the taxonomic family level, right? But beyond that, they say that there's no further relationship. This is a common standpoint taken by many major creationist organizations, probably the majority of major creationist organizations now in the present. And yet, so I mean, within the taxonomic family level itself, there is significant variance, right? And even between groups that interbreed, right? Take, for example, camel and llama. They can interbreed, right? They're in the same family. They can even interbreed, but there's significant anatomical differences, right? The camels have those big humps on their back. Llamas do not, right? And so, or, you have horse and zebra, right? They obviously have very different, like, appearance, right? And you know, and then also the donkey, right? The donkey does not even have the same vertebral formula as horse and zebra, right? And so, um, and also between these groups within families, you have significant amounts of genetic information not shared between these different groups, right? So, within a family, different species within a family do have significant percentages of their genome are not shared, right? In some instances, they don't even have the same number of chromosomes, right? Like a horse versus a donkey, they can interbreed, but they do not have the same number of chromosomes, right? And significant amounts of significant amounts of their genome, right, not shared, and the differences of their genomes differ within nested hierarchical patterns within families, right? And okay, but so then taking it further, what all am I getting at? So we see that there are many taxonomic families, right, that one from the next, just to about the same extent that we could say that in spite of the differences between different species within a family, that they overall, by and large, are more or less just different variants of the same thing. Likewise, between families, right? We have, so, like, to say that they, so to draw the line at family, right, you're having to have many different groups with independent origin, right, that, like, as far as their ancestry, right, and yet overall more or less the same, right, for practical purposes. They really, they don't really have to be any different, right? Take, for example, frogs, right? If you saw a frog hopping around, would you know if it's this family or that family? If you saw two frogs outside, would you actually know if they're in the same family or not? If you're not like someone who like professionally studies amphibians, you probably wouldn't know, right? And they more or less is mostly variants of the same thing, mostly all of the same organs, practical purposes. It's mostly just different variants of the same thing, right? And so, you would have to have several independent groups which are, practically speaking, mostly identical to each other, right? Mostly just variants of the same thing, right? And we also have many large groups of worms, right? Of which some of them there are hundreds of families, right? So you have ribbon worms, earthworms, flatworms. Some of these, it gets into hundreds of families, right? And yet they're just worms, right? But hundreds of families of them, right? And with birds, right? If you were to see a bird outside, if it's one family or another family, oftentimes, it's not always particularly apparent. They two birds of different families could still look mostly identical, and inside and out they would be most of the same anatomy, mostly identical, not just superficially what they look like from the outside, but inside and out, right? It's mostly all the same parts and doing most of the same things. And so we have these large groups that are just, mostly just variants of the same thing, right? And then, like I've talked about in other videos, even with the amount of like differences between different classes of animals, right? Like mammal versus bird, right? It goes vastly, the differences between the groups go vastly beyond what is practically necessary, right, for practical purposes and in nested hierarchical patterns, right? So, for example, right, you have bats. Bats fly in the sky like a bird, right? And yet bats are mammals, right? And we have mammals with so many different lifestyles and environments, all mammals, right? But some live in the water, some fly in the air, some climb in the trees. In the case of us, we're bipedal, and us humans, we are mammals. You have all these many different lifestyles and environments, and yet for all these many different creatures of mammals, the mammal setup works, right? Including flying, right? Bats, they fly like a bird. Humans were bipedal like a bird, right? And so, practically speaking, the entire differences between mammal versus bird do not actually have to be as they are, right? And yet it's predictable based on which group that something is a part of, right? And so, I mean, mammal traits, right? Like having 7 neck vertebrae, exactly 7, right? No more or no less. Almost all mammals have exactly 7 neck vertebrae. External ears, right? The fact that we have external ear cartilage, right? Most mammals have that, and only mammals have that. And 3 middle ear bones, right? 1 lower jawbone, heterodont teeth with incisors, canines, premolars, and molars, a neocortex, a diaphragm. Birds do not have a diaphragm, but all mammals do. An epiglottis, hair, sweat glands, mammary glands, sebaceous glands, right? All of that. And lacking various features that birds have, like almost all birds have a two-chambered stomach. Most mammals, including bats, have a one-chambered stomach. And birds have air sacs, it's called. Bats do not. All birds have beaks. All birds have feathers. They obviously lay eggs. Uh, they have a vocal organ called a syrinx, which mammals do not have. Uh, mammals have tonsils, lymph nodes. Most mammals have a rhinarium. We do not, because we're haplorhine primates, and haplorhine primates have dry noses, unlike most mammals, right? But most mammals, including bats, have a rhinarium. Birds do not. And most mammals have dichromatic vision. Because us humans are catarrhine primates, we have trichromatic vision. So catarrhine primates are an exception to that. But that applies all across the catarrhine group, in everything from baboon to human. Or I don't know if there's any exceptions, but most catarrhines at least. All of those features, though, all of those many different features of mammals differing from birds, they work for so many different creatures doing things so many different ways. And they even work for bats, which fly in the sky like a bird, right? And so even the entire differences between classes of animals, practically speaking, are totally unnecessary, right? Do not even have to be that way, right? And so what's absurd then is that, when even the differences between different classes do not really need to be that way, but you're going all the way down to the family level is where you draw the line. And so different families of frogs, which more or less are this just variants of the same thing, right? But you're drawing the line there for some reason, right? And different, earthworms, right? One worm from the next, right? All of these different families of flatworms, and for some reason there needs to be all this diversity of worms, and yet all mammals have to follow this super narrow criteria, like in ways such as almost all having exactly 7 vertebrae in the neck, right? But then, for them to accept up to the family point, right, they're already agreeing that, hundreds of species could all branch back to a common ancestor, right? They'll oftentimes say like, oh, Darwin showed that you could have variation of finches, but they're still all finches. And it's like, you realize that finches are a group of hundreds of species. There are hundreds of species of finches, right? So if you agree that they're all related, then you're agreeing that hundreds of species all branch back to common ancestry. That's already a large amount of evolution that you're on board with, right? And really, why would you draw the line at finches, right? There are other groups of birds that are mostly identical to finches, right? And so why draw the line there? Why draw the line at finches? Why not take it back further, and certain other groups of birds also branch back to shared ancestry with the finches? There's really no reason to draw the line at finches, right? Earthworms, right? We have over 20 families of them, right? Roundworms, we have I think hundreds of families of them, right? In fact, a very large portion of the phyla of animals we have are worms, right? There are different groups of things that we would call worms, and many of these groups have hundreds of families of worms, right? And yet within groups like mammals, we have such narrow criteria of how things will be, right? Diversity between groups, but then within groups, very narrowly following criteria of how they will do things. And so, it you know, it defies practical reason. It completely goes beyond practical reasons. Uh, it only makes sense through common descent, right? Especially also when we see the reproductive dependencies that species have, right? A human baby cannot grow without the mother's womb, right? A chicken baby cannot grow without the egg of its mother, right? And these reproductive dependencies themselves are predicted based on the nested hierarchical patterns of life. So, all right, that's all for now. See you guys.